So, the next one of our presentations. The theme, or the thesis, is Storms in the Brain. Are they predictable? Will you please welcome to the stage Ehsan Negahbani.
Good evening. First of all, I would like to thank my family who are thousands of miles away from here because of their endless love. Thank you, my supervisory panel here in Waikato University, and my special thanks goes to Alistair Steinras, my chief supervisor, because of his support and advice. Thank you everybody for coming this evening and supporting us. It is much appreciated. Let me to introduce one of the most complicated creatures in the world. Ladies and gentlemen, please don't think about the galaxies. I'm talking about human brain, which is composed of billions of that kind of cells, neuron. Let's do a very simple electrical measurement on it. Have a look at the voltage, which is due to different ionic concentrations among its membrane, and is a characteristic of a living neuron. Because our neuron is alive, so he has the right to have some fun. How? By opening and closing the ionic channels on his membrane, he can play beautiful songs. However, he is not the only resident of our brain. He is in communications with billions of other neurons, which will respond to him by singing and playing as well. And this will be the lovely life symphony. But sometimes, because of some reasons, this orchestra will refuse to perform properly. Instead of playing trumpet, they will blast in their vuvuzela. And the saddest story will happen. A storm in the mind. Biologists call it seizure, and suddenly the person will fall down. About 50 million people in the world are suffering from these seizures, and the very interesting question is that, are they predictable? Lots of valuable research has been done by biologists in this field, but unfortunately still many unknowns. So recently, mathematicians decided to help biologists. How? Based on biological evidences, they have offered some mathematical equations. The very interesting thing about these equations is that if you solve them and plot the result, you will find a mimic of real biological records. So we have a kind of mathematical model capable of reproducing real biological records. All right. What am I doing in my PhD research? Generally, I am playing with these equations, where in my virtual lab, which is my computer, I'm doing lots of analysis on these equations, solving these equations, finding the result, comparing them with biological records. Are they agree? If not, it means that my model needs some modifications. So I will repeat this loop until somewhere I will get consistent results. And this is where I have reached a kind of intelligent mathematical model which is capable of describing underlying biological phenomena such as that seizure and maybe predicting these storms. Thank you.
Good Lord, that is fantastic. I did a year of philosophy of the brain at Otago University and came out more confused than I was when I started, so that is fantastic.